Hello Year 6. This video is to help you think about working more efficiently, and we're going to focus on question 9 from the White Rose worksheet. Because with a question like this, the way that it's set out, it can almost encourage you to go about it in a long way and go in multiple steps. And we're going to talk about how the more steps you do, the more chance there is for a mistake, and how we can solve a problem like this a little bit more efficiently. So let's have a look at the question itself. And here it is. It says A, B and C are points on a number line, and you can see A, B and C there, and you can see how far along on the number line they are between 100 and 200. And it says how much greater is the difference between A and C, so from A to C here, than the difference between B and C, so B to C here. And because of the way it's written, it almost forces you to work it out in this way. So we can have a look, and the first thing it wants you to do is to work out the difference between A and C. So you can see point A is here, 118.76, point C is 186.34. So we can work out the difference there and do that calculation. So let's work it out the way it's almost forcing you to do it first. So we can do this, and we can see we've got a little bit of exchanging that needs to go on. I'm just going to change colour there because you might not be able to see that very clearly. So we're going to exchange, and that's a hideous looking T there, one of our tenths for 10 hundredths, and then we have 14 hundredths take away 6, which gives us 8. That is a very wonky 8. And again, we're going to have to exchange because we've got 2 in our tenth, we need to take away 7. Don't want negative numbers. So we're going to exchange one of our 6 ones for our, now we've got 12 tenths here, take away 7 is 5. They're very angular, it's got a robot drew them. Then we move to our ones, and can you see how much exchanging already is happening here? And each time we exchange, there's a chance that we can make a mistake. So there's lots of chances here to make a mistake, because now we're in our ones and we're having to exchange again because we've got 5 and we need to take away 8. We don't want negative numbers, so we're going to change and exchange one of our 10s there, leaving 7 for 10 ones. So now it's 15 ones take away 8. So that leaves us with 7, robotic 7. Finally, we don't have to exchange. We've got 7 tens take away 1, leaving us with 6. This is going to be hideous to draw on my mouse pad. And then we've got 100 take away 100, which leaves us with nothing. And I'm going to save watching me draw out a hideous robotic 0 there. But do you see how many times we exchange, and each time there's a chance to make a mistake? But we have worked out the difference between A and C. It's 67.58. Now if we read the next part of the question, we then need to work out the difference between B and C. So this smaller gap here, the difference between 159.72 and 186.34. So then we would have to do that, and the calculation would be this, 186.34, and we need to take away 159.72. So again, this is another chance to make a mistake, because we first of all have to write down the digits correctly, then perform the calculation. As you can see, we're going to have to exchange again, not in our hundredths, because 4 of hundredths take away 2 hundredths is 2, but now in our tenths we're going to have to exchange again, and that's another opportunity for mistakes. We're going to take one of our ones, leaving 5, and that's going to give us 13 tenths. We're going to take away 7, that's going to leave us with 2. Put in our decimal point there, and again in our ones you can see now we've got 5, we need to take away 9, so we're going to have to exchange again from our tens. That will leave us with 7, and we're going to exchange that for 10 ones. Now we've got 15 ones take away 9 ones, that leaves us with 6. At least my 6s are getting better. And finally, now exchange 7 tens take away 5, which leaves us with 2. So that would help us work out the difference between B and C. But there's a third stage to this problem, answering it this way. So another opportunity to make a mistake. Here it now asks, well, what's the difference between the distance from A to C and B to C? So now we'd have to take these two numbers, because this is the difference from A to C, and this is the difference from B to C, and find out what's the difference between these two. So here we go again. Now we would have to work out this, the difference between those two values. So again, we'd have to do another subtraction calculation. So again, there's yet more chance to get things wrong here and make mistakes and come to the wrong answer, because we could have made a mistake on either of these calculations. We also then need to make sure that we've written down the numbers accurately. So 67.58, 26.62, so far so good. But we have to do yet another calculation. So we have 800ths take away 200ths, which would leave us with 6. That's a much better 6 this time. And now in our tenths, you can see yet another exchange, yet another opportunity to make a mistake. So we're going to have to exchange one of our 1s, leaving 6 for 10 tenths. So now we have 15 tenths take away 6 tenths. That would leave us with 9. That's a very poorly drawn 9, sorry. Fortunately, our 1s, 6 1s take away 6 1s, just leaves us with no 1s. We need to write that in as our placeholder. And then we've got our 10, 6 take away 2 of our 10s, leave us with 4 10s. So we'd come to a final answer of 40.96, but that has taken 3 steps in which there are quite a lot of opportunities for us to make a mistake, with exchanging, with writing the answers from each part of the calculation into the final one we have to do. So I wanted to show you actually there is a much simpler way of doing this, and it only involves one calculation. So your chances for a mistake, it's a third of doing it the way that the question is almost forcing you to. So if we have a look at the question, all it's really asking is how much greater is the difference between A and C and B and C. So you can see actually that difference is this distance here, the difference between A and B. So if I just show you, actually what it's really asking is what's this distance here, because that is the difference between travelling from A to C over here and from B to C here. So actually the question only really wants to know what is this bit here worth, and that is only one calculation. So we could save a lot more time and just find the difference between A and B, because that is going to be the difference between A and C and B and C. And here you can see just one calculation. So if we find the difference between B, which is 159.72, and A, which is 118.76. Now let's see, it should give us the same answer that we worked out doing it in the 3 stages here, but we'll just double check. So we have 200ths take away 600ths, so we have an exchange, so we're going to have to take one of those tenths, leaving us with 6, and exchange it for 10 hundredths. So now we have 1200ths take away 600ths, so that gives us 6, and then we're going to need to exchange again, because in our tenths we've now only got 6 and we need to take away 7. So I'm going to take one of my 1s, that's going to leave us with 8, and now I have 16 tenths take away 7 tenths, that leaves me with 9 tenths. Decimal point, and then we have our 8 1s take away 8 1s. It's a poorly drawn 8, sorry. That leaves us with 0, and then 5 10s take away 1 10, leaves us with 4, and then we'd have 100 take away 100 be 0. Don't need to write that in, but as you can see we have ended up at the same answer as doing it in the 3 steps here. Both times we got 40.96, but this was a much more efficient way, because we just thought about the question logically and thought, well, the difference between them is just the same as the difference between A and B here. So why not just do that calculation, keep it to one calculation and reduce the chances to make mistakes, because here we've only had to do, as you can see, 3 exchanges. You look over here, look how many we've had to do. This one, horrible mess over here. So it just minimises those chances to make mistakes, and it makes us a little bit more accurate and a little bit more efficient. So hopefully that's got you to think about how we can be a bit more efficient, and I'd like you to think about how you could do something like that with the question with Tommy's pieces of string, because there are more efficient ways of answering that one as well. So I wonder if you can have a think and how we might solve things a little more efficiently. But hopefully that's helpful, and good luck. Bye.